All right. Good afternoon, everyone. I'm Karen Durante with FCA International, and we are very pleased to welcome you to our educational session today, which is Surface Preparation and Your Business. Our presenter today is Carl Sabo. Carl, an industry expert, and we mean that, is the Technical Director, Protective Coatings at the Pittsburgh Paints Company. Carl has 46 years, which I said to Carl a little while ago. I can't even believe it. You don't even look 46, Carl. But Carl has 46 years of protective coatings experience. He is a member of AMPP, ASTM, and is also an AMPP Senior Certified Coatings Inspector. Carl has a BA in Marketing from Cleveland State University. Carl, thank you very much for joining us, and I'm going to turn it over to you so you can get
Well,
started.
thank you. And certainly on behalf of myself and entire PPC organization, I want to thank Tony and Karen, Olivia, and the entire FCA organization, and of course, all of you on this call for allowing me to spend a little time with you today. So, as Karen said, my name is Carl Sabo. I am the technical director at the Pittsburgh Paints Company. Yeah, I've been doing this for quite a while. I reside in Cleveland, Ohio, and spent almost 30 years at a coatings company based in Cleveland, where I started there when I was 16 years old. So, been able to do a few things. Don't have all the answers, gang. If I ever think I'm the smartest guy in the room, I'm going to find a new room. But we're going to talk about surface prep today and how important it is and how it can impact your business. So without further, let's get into it. All right. So what is the goal of surface preparation? And you can see these two very nice bullet points, right? To achieve a bond between the coating and the surface, right? To sustain a durable and attractive finish. And without good surface prep, a coating system will fail or not last as long as everyone hopes. So cutting through all the fancy bullet points, we want the paint to stick, right? We want it to meet owners' expectations. We want surface prep to be something that your organizations do and are able to articulate the importance of surface prep to your clients and why it's important and why you should get your just pay for doing the surface prep. And hopefully, at the end of this, you'll get somebody's answer, somebody's whys reinforced for you and articulated. So the coatings industry estimates, and you get different numbers, but 75% of all failures are due to improper surface prep, right? So again, working for a paint manufacturer for all these years, we're not crafting parts for the space shuttle. Making paint is pretty simple. Okay. So, 75% is surface failures. About 1% to maybe 2% of all failures are due to bad product. Okay. That's a fact. I know I'm talking to folks here who put on paint for a living, but this is Carl telling you. This is the industry. So if you take 75 and 2 for bad paint, that's 77. I'm not a real smart guy, but that leaves 23%. Okay, so you're probably thinking, well, Carl, where's the other 23%? If 75 is bad prep, 2 is bad paint, the other 23 is a bad recommendation. And, that could also fall on the manufacturer, right? So I would ask all of you respectfully, always lean into your manufacturer, okay? Let them tell you what the coating system should be, okay? If you're kind enough to buy our paint or whoever's paint, that's the least we can do, right? Is to give you a recommendation, okay? So the byproduct of improper prep is, in reality, is that you got to send your crew back out there to correct the failure. Okay, regardless of who's on the hook, you got to go back out there, and that drains profitability from your project. But like I said here on the onset, I want to give you some of the whys behind surface prep and why it should be done a certain way. And if you could articulate that to your owner or specifier, right? I look at the paint business as a triangle. You got an owner, right? Call it Sitco Petroleum just for the sake of just pulling a company out of my hat. Okay, you got a specifier that could be a large design build firm, an engineering firm, an architect firm, and we got an applicator, right? So, and those are businesses like yours that apply coatings for a living. So, if you want to, what I'd like to see, articulate here is to explain the why. And if you have to explain that, if you're doing work for owner direct or you're doing work through a GC, I want to be able to give you some information that you could tell these folks why you're prepping and why it costs what it does. So a properly prepped surface will undoubtedly uh, prevent material waste, right? A nice, properly profiled surface. Proper preparation enhances corrosion resistance. It just does. Okay. Um, and you'll see, I have a slide here a little bit later, gang, that there's a direct correlation between surface prep and coating service life. So, it's either a pay me now or pay me later thing with a building, with a facility owner. So typically when we're preparing a steel, any type of steel, a ferrous metal or non-ferrous metal, most often we're using some type of blast media for abrasive blast cleaning. And obviously we have hand tools and power tools and things like that, water jetting, right? Things of that nature. But we're going to spend a little time here now and talk about blast media. And obviously you guys know what this is, right? It comes out about 800 miles an hour with compressed air or air and water to strip, etch, or smooth surfaces by removing the old finish, rust, mill scale, etc. Okay. But what is important to know, gang, is the thicker the coating system in mills, really the more depth of profile you need. And we're going to get in, and we're not going to get real deep into the uh, blast surface prep standards, but understand this. Those are cleanliness standards. Nowhere, absolutely nowhere in those standards that tell you how deep the profile needs to be. Okay? So understand that. Inherently a white metal blast might get you a certain profile because you got to work that nozzle. But a properly written specification is going to call out the level of cleanliness and the depth of the profile. Okay? So, and we'll probably get into that a little bit later here. So how does blast media choice impact your bottom line? Cheap media shatters, right? You're not getting the same amount of coverage per foot per hour. Uh, Different medias, higher quality medias cost more money, right? But they clean faster, right? They last longer, and you're consuming less, disposing less, right? Low quality media, you're going to burn through more pounds per job. High performance media lowers the total volume needed, right? So, right, I just talked about disposal and cleanup costs, and using overly aggressive media on a delicate surface can cause harm, right? And we're going to get into this again, gang. And you guys are the experts in this, okay? I'm more of a theory guy. I never professed to be a professional painter, okay? All right, I'm I held a blast nozzle, sure, an airless spray gun, sure, an air assisted airless, an air driven, sure, yes, but you guys are the experts. I'm not, okay? But one thing you got to be cognizant of, gang, is you obviously you don't want to use a metallic media if you're abrasive cleaning stainless steel, right? And I'll show you why a little bit later, because you're going to get that whole phenomenon by corrosion by dissimilar metals, right? You don't want to use a metallic abrasive if you're blasting metal, okay? So, like I said, we'll get into that a little bit later. So, the blast profile must be appropriate for the film thickness of the coating. You got to have enough blast profile, or enough coating rather, to cover your profile, or it's going to look like this. All right. You get a call and say, oh man, I need you to come out and look at this. I think there's a problem. And you look at this and you may say, well, son of a gun, maybe it's a paint problem. Okay. So you call me, I go out, I look at it, and I see this. Okay. And I see, wow, that's a 1.85 mils of dry coating. And let's just call that a slightly under applied coat of a direct to metal acrylic. If you look at a DTM data page, may it be ours or whoever, that product is a 2 to 4 mil dry product. Fact. Okay. They're all in the 40 some solids. They all, you put on 5, right? You're going to get about 2. 5 wet, 2 dry if it's 40 solids, something along that. So you see that on the left there at 1.85. That's pinpoint rusting. Okay. And a little bit down the road, you don't see that phenomenon, right? 2.6 mils. All right. Paint's not that smart. If I'm the flipping paint, I'm not saying, oh, I'm going to screw with this surface. I'm going to look like SHIT on the left. I'm going to look great on the right. Okay. So where you see 2.6 mils, it looks good. So what I'm looking at here is probably a 2 mil profile on that surface. Enough paint isn't put on there. It was light that allowed the pinpoint rusting to occur. Okay. On the right-hand side, you have enough paint to cover the profile. Okay. So this, in all due respect, this isn't a paint quality issue here. Okay. It's not. So, okay. I get it, Carl. Makes sense, but it still looks like, you know what? I got to fix it. What the hell do I do? Okay. Pretty simple solution, right? Just don't overthink this. Make sure you clean it. If you're using acrylic paint, you got to wipe the surface down with one of 2 things: acetone or denatured alcohol. And you're like, well, son of a gun, I got a drum of xylene in my truck, or I got some MEK. Can't use that stuff. They have hydrocarbons in it. It leaves an oily residue, right? Acetone and denatured alcohol do not contain hydrocarbons. It's not going to leave that oily residue that's going to impede adhesion. Just have your guy go out there, or gal, and put more paint on. Okay? They might have to feather it in and make it look pretty, but if you put more paint on, you're going to cover the profile and all things are going to be okay. Okay? So, let's talk about some ramifications of under applying coatings. You got to rework it, right? Redoing a failed coating job may cost up to 4 times more. You guys know that number. I don't. Okay. But I think we can all agree that it's going to cost you more, right? Labor duplication. You're paying twice for the surface prep rigging and the application. Scaffold rentals, right? These are all things you guys do daily, not me. Schedule disruptions, right? If you got to go back, you could be deploying that crew to a new project to generate more revenue. Material waste. You might have to mix small batches for touch up. You might have some waste. You might have some disposal, right? So supply chain strain, right? You might have to get stuff shipped in depending on who you're buying from. Not everyone has good distribution. You might have to use a coatings company that has minimums that ships from somewhere, right? So that can be a bigger concern with certain companies than others. Maybe you take a ding to your reputation, right? Clients will not renew maintenance contracts, right? You might have some negative word of mouth. In today's day and age, it's unfortunate. You guys are the business leaders, the business owners. I'm not, and people are flipping nuts. They put stuff on the internet, on Yelp and everything else that is crazy. All right. How do you measure surface prep? And again, we're not going to get into weeds here a lot, but that's called Testex tape gang, right? That's a piece of abrasive blast clean steel. That's extra coarse Testex tape. You take it. There's a burnishing tool there you see on the left. Almost looks like a swizzle stick. Extra coarse tape measures from 1.5 mils to 4.5 mils. You rub that circle, right? You peel it off. You put it in a micrometer. It measures the indentations that you're going to impart into that circle, that piece of cellophane, so to speak, right? You stick it into a micrometer. You press it. You subtract 2 because the tape is 2 mils thick. Mike's reading 5.5. You're getting 3.5. Okay. So that's a real quick on how, of a manual way to measure surface profile, right? A lot of you guys probably got the electronic instruments, right? Falsco makes them. A lot of companies make them, right? The old Positector 6000, things like that. Who writes these standards, right? AMP, ISO. ISO is more of an international concern. Sometimes if you guys are doing work for multinationals, you might see surface prep methods that are ISO SA 2.5, right? Or, that could be SSPC SP6. Or, so if you ever come across that, you need clarity on that, get a hold of your paint rep for, whoever that would be, from what company you're doing the project with, and they could be able to talk that through for you for sure. Right? Knowing surface prep standards, in my mind, is just good business, right? It eliminates rework. Coatings fail on poorly prepped surfaces. Redoing a job right destroys margins. We kind of hit on that a couple slides ago. Proper surface prep and profile ensures accurate paint coverage. So you're if it's done properly, you're using the right amount of coatings. You're not using too little. You're not using too much. You're right there. Okay. Lowers labor expenses if you do it right the first time. It extends equipment life, right? If you're using correct standards, less wear and tear on your blast equipment. There's other ASTM standards you should be checking. If any of you on the line are doing abrasive blast cleaning, you got the ASTM test to check for oil and contaminants in your media, and you also got the blotter test that checks for clear air going through your nozzle, so you're not contaminating your media. So that should be done fairly regularly. Those are I don't have the ASTM numbers to memory, but it's called the vial test, where you shake a small vial and check the cleanliness of your media, and then you got the blotter test, where you blow air through your nozzle into a blotter and look for how clean it is. Revenue and market advantages. Industrial clients often require certified standards. Knowing them qualifies you to bid. Sometimes, certain contractors might have to meet like QP1, QP2, things like that. I think you guys know some of those things. But knowing and having the certified people on staff, or knowing the standards, sometimes is a requirement, or a differentiator at the very least. Clear standards give your crew exact targets. Hopefully that increases efficiency in getting the job done on or before schedule. Fewer warranty claims obviously build stronger client trust. Trust brings repeat business. And obviously no one wants to get into any litigation, right? Everyone tries to do their best not to have to go there, for sure. Again, real quick, these are some of the AMP standards. I'm not gonna get crazy with these, but let's get into it. These are for abrasive blast cleaning. We'll talk about. Everyone calls these, gang, by the SSPC number. Very often, very infrequently do I ever hear anyone call white metal blast an ACE1. Everyone calls it an SP5. Hey, NACE came in after the fact, gang. Believe me, I've been a NACE member for over 30 years now. AMP, right? Karen talked about my credential. Oh, okay, big flipping deal, right? I'm NACE level 3, whatever they call it now. But SSPC did these standards, okay? And why? It's a real telling reason why. Look at the numbers: SP10, SP5, SP10, SP6. NACEs go sequentially, and SSPCs don't. Why do you think that is? Well, I'll tell you why. They first developed white, then they developed commercial, and then they decided they needed something in between. And they said, "Son of a, you know what? We already used the number 6, so let's flip and call it 10." Okay. And then NACE came in and said, "Oh, great, let's partner, let's do this, and we'll call ours 1, 2, 3." Right? So that's that reality. So SSPC SP1, gang, this is really, 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 really important. Okay. SSPC SP1 is solvent cleaning. It is implied in every other abrasive blast cleaning standard. But what is extremely important, gang, here is this is a method of removing visible oil, grease, cutting compounds, and other soluble contaminants, right? The second bullet point, it is intended that solvent cleaning be used prior to the application of paint and in conjunction with the other prep methods. So there's two different types of contaminants, gang, and I know you know this. There's the world of visible contaminants as depicted on this slide, and you got the whole other arena of non-visible contaminants, nitrates, sulfates, and chlorides, right? Where you have to test for those. And there's certain parts per million thresholds that each manufacturer would like to have you achieve, right? What happens to nitrates, sulfates, and chlorides when it comes in contact with atmospheric moisture? What do you think nitrates become? Nitric acid, sulfates, sulfuric acid, right? And then it can cause osmotic blistering. Believe me, I've had some tough conversations over my years with hardworking, great craftsmen like the people on this call, but unfortunately had to say, hey, man, you know, you're doing this job on the water in California, right? Let me ask you, dude, did you check for non-visible contaminants? Well, no, I didn't. Well, maybe you did. Maybe you should have, right? Now, a good paint rep should have that in their specification, right? If you're doing jobs on water and salt water, you should be checking for non-visible contaminants. And that's what you need to articulate to the owner or the specifier. Hey, why didn't ABC painting? And again, no offense if there's ABC, I'm just throwing letters out. Why didn't XYZ painting tell me this? Because they didn't flipping know. Okay? So again, these are some of the whys. And you could get your right dollar for this. And it differentiates you and it raises your level of expertise compared to maybe another contractor for a contracting firm that you're bidding against. Right? Wow. Oh, that's I should. Yeah, that's a great idea. We should test for non-visible contaminants. We are sitting on a body of salt water. Oh, interesting. Oh, that bid is a little higher, but this guy knows this company knows what they're doing, and they're trying to prevent a premature failure. Okay. Hand tool cleaning, gang, real quick. You often see this in conjunction with SSPC2, hand tool, SSPC3, power tool. It's the same level of cleanliness, gang. If you read this, it's a method where loose mill scale, loose rust, loose paint, and loose detrimental foreign matter is removed. So is there stuff left on the surface? Doggone right there is. You're only removing the loose. So what's considered not loose, or let's call it tightly adhered? That is, you go over the surface with a new putty knife, not one that's been in your craftsman's work belt and has been sharpened. You need a new dull putty knife. You go over the surface, and what isn't lifted by the dull putty knife is considered tightly adherent. But folks, I got to tell you, what's tightly adherent today might not be tightly adherent next month, next week, next year. And that is what you have to articulate to your customer, your owner. Hell, we all make paints that are surface tolerant, that are engineered to go on tightly adhered rust paint and mill scale. All of us do. Okay. But there is, again, we'll get into a slide on this. There's a direct correlation between how clean the surface is to how long the coating system is going to last. And if you give an alternative to abrasive blast and it costs X amount more, and I'll show you that a study that was done, how much longer it lasts, it's probably a better value to your owner. And maybe you could get more money for doing that prep, and everyone wins. Okay, I'm not going to go over SP3. I just said it's the same level of cleanliness as SP2, but you're using a power tool. Okay. Couple examples of some power tools. All right, let's get into the abrasive blast cleaning. This is white metal blast. Everything is removed, right? All visible grease, oil, rust paint, mill scale oxides, paint. It's all removed when viewed in a 9 square inch area without magnification. Okay. When would you typically do a white metal blast? Typically, we reserve white metal blasting for a coating system that's going to go in immersion for the most part. Okay. Even inorganic zinc gain, you could get away with an SP10. Okay. An SP10 gain, it still has the same, everything is still removed. If you look at the second bullet point, that isn't 5% of paint and rust remaining. That's just 5% of residual staining. Okay, minor discoloration caused by stains of rust, mill scale, and things like that. Okay, that's near white metal blast. You do it a tank lining job that you're taking off an old system, an SP10, 99.5 times out of 100 is sufficient. Okay, gang? Here's the one you guys probably do for those of you on the line that are doing abrasive blast cleaning. SSPC SP6 is commercial blast cleaning. Please understand, everything is still removed. That 33% is the residual staining or shadowing from all the rust you took off the steel, right? All the mill scale, all the previous coatings, right? For atmospheric exposure, this is the abrasive blast clean standard that you could get away with 98% of the time. All right, we just went through these 3 standards, and nowhere does it call out how deep the profile is, like I said on the onset of this presentation. Right, SSPC SP7 is a brush-off blast cleaning, made a lot of times used for repaint applications. Gang, a brush, as you guys know, a brush-off blast, sweep blast, whatever the hell you want to call it, is you still got stuff left, tightly adhered. Okay, so that is, just be careful when you're abrasive or a sweep blasting, because if you get a little bit too thorough, you could fracture the paint that's still left on the surface, and then all hell breaks loose when the new paint is put over it and the surface tension and the new stuff biting down and drying. So if you're sweep blasting or brush off blasting, please do exactly that. Okay. And again, these aren't all the standards, right? Come on. I mean, there's SSPC SP16 for non-ferrous metals, right? For galvanized. I mean, I just wanted to kind of give you a little flavor here. Here's water jetting, gang. Understand, water jetting does not create a profile. Straight water. I didn't say water mixed with sand, okay? Straight water. Even at 25,000 PSI. It's going to blow your foot off if you don't have your right PPE on, but it's not going to put a profile on the steel. Okay? So again, water jetting, ultra high, water jetting is really, really prevalent in the marine industry. Not to say you guys haven't done it or can do it, but you got to put the flipping water somewhere, right? So just know that. Types of abrasives, right? Right, sand. A lot of times folks aren't using sand too much anymore. But you have garnet, right? Mineral slag, Black Beauty. Black Beauty's a trade name. What is it? It's a mineral slag. It's typically coal slag, right? Steel grit, steel shot. I said this, on the onset or shortly thereafter. Don't use steel grit and steel shot if you're blast cleaning stainless steel. Okay. You got your organic media, corncob, walnut shells. You got glass, baking soda. Sometimes, baking soda, that'll get a surface clean, but it's not going to do anything to create a new profile, right? Or it'll expose the existing one. Okay. All right, gang. I told you that there's a direct correlation between the coatings cleanliness and service life, right? Hey, this isn't Carl Sabo talking. This is, you can see the source right here below. And this is a typical epoxy mastic urethane system. Call it Amerlock 2 with Pittsburgh Ultra. Okay, call it that. That's an epoxy urethane system. So if you do an SSPC 2/3, that's a hand tool, power tool where tightly adhered rust paint mill scale can remain in a severe exposure. Let's call it a chemical plant. This report's telling us that this system is going to last about 6 years in that environment. If you up your cleanliness to a commercial blast where everything is removed, 33% random staining viewed without magnification in a 9 square inch area, that same system will last 9 years, according to this study. So if you're trying to sell a certain prep to your owner or specifier, you could call to this report, to this document. And that's why I am recommending this. I could do SSPC 2/3 for this dollar amount, but if you want this, here's what you're going to get for the cleaner surface. And you can see it in a mild exposure. You know, say you're at I don't know, you're in Des Moines, Iowa, in a cornfield. Okay, if you're not by salt water, you're in it's pretty temperate for the most part. You're going to get a little longer performance. So how does surface prep impact service life, right? Failure to remove all types of contaminants, may it be visible or non-visible. If you prep right, you get rid of the contaminants, it's going to last longer, right? You're going to need that for the most part, gang. Your profile should be at least 15 to 20%, at least 20% of your dry film thickness. You got a 10 mil coating system. You should get at least a 2 mil profile, say 20%. Okay. The increased profile gives the coating system more area to mechanically bond to. Sure, you're going to use a little more paint. Okay. Who we fooling? All right. But the important thing is here, gang, that a good profile is going to increase the surface area so the paint has more contact areas. Okay. Equipment life cycle improves, right? We kind of talked about that. Hopefully, if you're not going to rework, you're mitigating the risk of on-the-job workplace incidents, right? And less incidents, I'm sure, probably cost you guys less in premium. And hopefully, doing the job right, giving your crews the right information and the right equipment, hopefully keeps morale high, and folks are continue to take pride in their work, right? I don't know. I'm sure you guys know what stripe coating is, gang. Stripe coating is very important. I like to write it into my specifications, especially if we're dealing with a lot of nuts and bolts and angles, because those are the first areas to fail, because those areas are hard to get proper millage on. Paint millage, dry film, because paint inherently pulls away from edges when it dries. Okay, so what is a stripe coat? A stripe coat is a full coat of paint. You can do it by a brush, a full coat of paint on those hard to coat areas. You can see on the slide here, for those of you watching, weld seams, nuts and bolts, edges. Okay, you can see how if you do a stripe coat, you can see how it improves coating service life. Again, you're trying to sell this to the owner, and you're trying to sell this to whoever the specifier is if you're working for them. And they might say, okay, I understand. Why the hell did company XYZ write a stripe coat into their spec? They weren't thinking of it. Okay. So, again, sometimes the owner might say, dude, I don't want to pay for it. But you could sleep at night telling them this is the benefit, right? And that, unfortunately, you might have to tell them, I told you so. I told you so. Okay. There you go. All right, corrosion by dissimilar metals, real quick. This is why, gang, real quick. This is the galvanic scale. Things near the top are much more active or less noble. On the bottom are least active, more noble. You see zinc, number 2. You guys put zinc primer usually put it on carbon steel. The more active metals will sacrifice themselves to protect the least active metal. That's why zinc primers work. They give you galvanic protection. But you might go look at some job sites, gang, and I'll get into it in a second. But no, I'm going to get into it now. I'm going to go to this slide. If you have metals, gang, of two different activities, so to speak, and they come in direct contact with each other, that's called corrosion by dissimilar metals. As you can see here, this is probably a stainless steel band that is going on a carbon steel pipe, and there's probably some paint on the other side of that band that it moved up and down, and that band started hitting the carbon steel. Look at your doggone license plate. The BMVs aren't metallurgists. They're selling you license plates with any type of flip and screw, and sometimes you'll see the corrosion where the plate meets the screw. Okay? These are examples of corrosion by dissimilar metal. And you walk a job with an owner and you see that, and you tell them, hey, dude, this is probably why you're seeing this, is because of this corrosion by dissimilar metal. And they said, wow, never thought of that. How do I fix it? Well, you fix it a couple of different ways, right? You could tell them to change the band and get it to the same metal. Buy a carbon steel band. I know your intentions were good here. Stainless steel bands are expensive, but if you know, it's a dissimilar metal, put a rubber gasket around it, right? So they don't touch each other, right? So again, these are the preventative actions that you want to do. Identify these problematic junctions, right? Like aluminum brackets touching steel screws. Include isolation hardware in your bid and articulate the why. And again, they might be saying, why the hell didn't anyone else tell me this? Right? So, yeah, I mean, you know, write this, make sure your firm is not liable if they go ahead and do that. That's just not a paint problem, gang, and it's not a product application quality problem. It's an engineering problem. Right? It's a maintenance issue problem. Don't be held on the hook for anything like this. Please. You know, in all due respect, it's not a paint problem either, gang. It's not. But, you know, just that if you're aware of it, make your client aware of this phenomenon. And if they're not willing to do any of these things to mitigate it, don't put yourself on the hook for this stuff. I mean, you know, it's your decision. I mean, you know, but just saying. I mean, right? So, gang, it is 2:38. That is everything I have. Are there any questions from the group that I could answer about anything? It'd be my pleasure to do so. Anyone? All right. Karen, are you still with us?
I am here, Carl. So no questions? Well,
I don't think there are.
Okay.
But you know, gang, if you need to get a hold of me, my email is very simple. It's the letter C as in Carl. My last name is Sabo, S-A-B as in boy O, Sabo at pittsburghpaints.com. It'd be my pleasure to assist you or deploy someone that can assist you locally. So again, I want to thank you for being on the call. I want to thank Karen and the team from the FCA for allowing me to spend some time with you today.
And Carl, thank you so much. Very informative presentation. And we very much appreciate you sharing your expertise with all of us. I have to say the Pittsburgh Paints Company is very fortunate to have you all these years. Again, it's hard to believe, 46 years. So thank you, Carl, so much. If anyone does have any questions and didn't have maybe a pen to write down or couldn't type in your contact information, feel free to reach out to us here at FCA. We're happy to help. we'll put you in contact with Carl so your questions can be answered. If there's any way we can help you, we are glad to do that. And from those of us at FCA, again, thank you, Carl. Thank you to those who attended today. I hope everyone has a great rest of your week.
Okay. Thank you, everyone. Bye, Karen. Bye, everyone.
Thank you, Carl. Bye, everyone.